Hello, this is our electric bicycle lift project for Dr. Elder's ME223 design class. Our team consists of Colin, Sowards, Stephen Sainsbury, and Ben Palmer. We are given the task to design and build a bike lift and turn it into a kit for individuals at home to assemble. We did this using reflective thinking, which allowed us to question our initial design and further improve. We hope this presentation gives you enough information and incentive to go design and build your own bike lift as well. Our problem definition involves designing a product with a fundamental knowledge that teaches basic engineering ideas. In this process, we hope to demonstrate good teamwork skills, to learn a lot, and to have fun doing so. We also see the need to create a safe product for the public. Our target customers include college students and professors interested in the fundamental ideas such as mechanical advantage, computer programming, etc. that this project has to offer. The goals we are trying to solve with our bike lift are clutter and mess in your garage at home. With a bike lift, you are able to suspend your bike up in the air out of the way, which allows you to be more organized and have more room for other things. It's always frustrating walking through a messy, cluttered garage, and by suspending your bikes with our bike lift, it becomes easy. We had several ideas for our bike lift. When we thought of the ideas of a bike lift, we automatically thought of it being in your garage at home, lifting your bike to the ceiling so it was less cluttered and you still had room to park your cars in the garage. Ways of doing this would consist of a motor attached to a series of pulleys and gears to perform the task of lifting the bike efficiently and conveniently. Our goal is to design a prototype that helps teach the basic ideas involved in designing an electric garage bicycle. Using pulleys gives us a mechanical advantage for lifting objects, in our case a 2-to-1 advantage. Though our little DC motor may not lift much, we are able to set up a system of pulleys to get a mechanical advantage and lift more. As you can see in the figures, when we continue to add pulleys, we get a greater mechanical advantage, but for every pulley you add, you also have to pull further to move an object a certain distance. Another way we were able to get a mechanical advantage and increase the torque of our motor was the use of gearing. This is another way to get mechanical advantage out of an object. Though our motor is small, we can gear it in such a way that it will lift a lot of weight. However, it won't be able to lift it very fast. The bigger the gear you use, the more torque you will get, but less RPMs or speed, and consequently more time, is a result of the big gear. Gears are very useful and are used in so many things we see every day. Some pulley designs of our kit consisted of using a dowel and a nail inside of a straw. As the string ran over the dowel and nail with the straw, it spun with very low friction, allowing it to act like a pulley. We placed these in two spots where a pulley was needed in our design to create a 2-to-1 mechanical advantage so we could lift more weight. We also tried several gearing designs. We used a dowel on the shaft of our motor for a gear, as well as a winding point for the string. This wasn't a large advantage, but the dowel was larger than the shaft of our motor and did create more torque. We also tried using a wooden spool and a cardboard circle cutout that was fairly large and would have generated a lot of torque if needed. These, however, turned out difficult and inferior to our final gear design. Potentiometers were very useful in our kit for our bike lift. A potentiometer acts as a variable resistor which allows an individual to control the current or flow of electricity. By being able to do this, we can control the rate at which our motor runs and how fast we can lift the object. It is important to have control over this for user safety. This gives them control to lift their bike at a rate that they think is safe. They are able to go as fast or as slow as they want and stop at any time during the lift. The motor we used in our bike lift was a 5-volt DC motor. This was used for smaller load and pulley system, which fit our design with the use of several pulleys and a small gear. We also have our Arduino here, in which we wrote a computer program to run our DC motor. We also attached a 9-volt DC motor to increase the lifting power. This is used for larger loads and larger pulley systems. However, a greater loss of efficiency resulted. Our solution to the problem of a cluttered and messy garage was a bike lift so that an individual is able to suspend their bicycles up and out of the way on the roof of their garage. This also helps reinforce critical thinking regarding engineering concepts. Rather than just providing hooks you can put in your ceiling and lift your bike up and hang it, we designed a bike lift so that individuals are able to clean up the garage and suspend the bicycles by the use of a convenient switch. Our first prototype of our design consisted of constructing a model of the corner of a garage with a dual pulley system with a 5-volt DC motor being ran from our Arduino. Our design also allows for the bicycle to stay in the back corner of the garage and up in the way out of everything. Our design is super convenient. It is cost-effective and easy to use. The bike lift operates off of a potentiometer or variable speed switch via Arduino, where any individual is able to clean up the garage and suspend their bicycles up and out of the way. We are all about product safety, and by having our design in the back corner of our garage, it keeps the user safe. We found the Arduino limited our power supply to our motor, and with the limited gearing we had, it was only able to lift the object slightly on a single pulley rather than a dual pulley system. So as engineers, we went back to the drawing board and adjusted a few things. Our final design consisted of several changes. We were not satisfied with the limitations of the 5-volt motor with the Arduino, so we designed a separate system consisting of a 9-volt DC motor with its own potentiometer and on-off switch. Although we had slightly less system efficiency, this setup enabled us to lift much more weight much more conveniently. However, we still enjoyed learning the code for the Arduino and what it had to offer. This is why our final design incorporates 2 separate motors, one with the Arduino, one without, with variable resistors for 2 different customer segments depending on the customer's preference. This is our program script for our Arduino that powers our DC motor. The program is very simple because of its basic function to run the motor through the potentiometer, and from there we adjust the current to the DC motor by the twist of a knob. Our data is as follows. The 5-volt and 9-volt DC motors each lifted our desired mass of 40 grams or weight of 0.3924 newtons. The 5-volt motor via Arduino and code provided about a 5% efficiency with a low lifting power. The 9-volt motor with switch and potentiometer provided a lower efficiency around 3%, but also provided a much needed lifting power. Our task was to prepare a kit, and any basic kit consists of some basic given materials to help you design your own product. Our bike lift consists of straws and dowels to make your own pulleys, popsicle sticks to build a garage, or in our case a corner cutout of a garage, duct tape to hold it together, string connecting the mass to our DC motor through a few gears and pulleys, and the Arduino to feature the potentiometer and to power the motor. In doing this project, we have learned many life skills. You can see them listed here. Without them, we wouldn't have gotten very far and learned nearly as much. We used critical thinking to maximize our results through questioning of our first design, which ultimately led to an additional separate motor and power system and an improved gear and pulley design. We then used reflective thinking to take these better ideas and improved until we reached our final design. All in all, we tied in the life skills, technical knowledge, and the fundamentals we have to create a marketable product that is easy to design and fun to use.